Well, a tsunami has hit the island nation of Tonga.
Take a look at this satellite video.
Breaking news. A tsunami advisory is now in effect for the entire U.S. West Coast and Alaska.
It's a very large explosive part of this eruption.
It began with a deep rumble beneath the ocean's surface, an event so powerful it sent seismic ripples across the globe. What unfolded next near the Challenger Deep, the deepest point in the Mariana Trench, has shocked scientists and captivated the world. An underwater volcanic eruption of unprecedented scale has erupted, revealing the raw power of our planet like never before. The Mariana Trench is one of Earth's most mysterious and remote locations, stretching over 1,500 miles long and plunging nearly 36,000 feet into darkness. It's a place where crushing pressures and frigid temperatures dominate, a seemingly alien world. For decades, scientists have studied its unique features, from hydrothermal vents to its bizarre ecosystems, but nothing could prepare them for what's happening now. A massive, previously unknown underwater volcano has awakened with explosive force, altering the seafloor and raising questions about the planet's dynamic processes. The eruption began with unusual seismic activity deep beneath the Pacific Ocean's floor. Instruments detected powerful earthquakes in a concentrated area, far deeper than routine tectonic shifts. At first, scientists believed this was just another event caused by the trench's tectonic plates, the Pacific Plate and the Philippine Sea Plate, grinding against one another. But the tremors intensified, and changes in water temperature and chemistry indicated magma was on the move. Then at over 20,000 feet below the surface, the seabed erupted. Torrents of molten magma, superheated gases, and ash burst into the ocean, creating shockwaves felt worldwide. The force of the eruption was so immense that it sent plumes of material shooting miles into the water column. A volcanic island is even beginning to form, a rare phenomenon reminiscent of how places like Iceland and Hawaii emerge from the depths. But the eruption isn't just geological, it's ecological. The Mariana Trench is home to extraordinary life forms adapted to its extreme conditions. Hydrothermal vent communities have been buried under ash and debris, threatening some species with extinction, while others may adapt in unexpected ways. As the magma cools, new habitats are forming, offering a glimpse into the resilience of life in even the harshest environments. Meanwhile, the eruption's chemical aftermath is causing ripples across marine ecosystems. The release of gases like sulfur dioxide and carbon dioxide has altered water chemistry, potentially triggering algal blooms and harming coral reefs. Even the possibility of underwater landslides raises concerns about tsunamis, putting coastal communities across the Pacific Rim on high alert. Yet amidst the chaos, the eruption presents a unique scientific opportunity. Research vessels equipped with cutting-edge technology, including autonomous underwater drones, are exploring the site. Early findings reveal magma-rich in rare earth elements, critical materials for modern technology. But this discovery sparks debates about the ethics of deep-sea mining and its potential environmental costs. The volcanic eruption serves as more than just a dramatic display of nature's power. It is a rare opportunity for scientists to peer into the hidden processes occurring deep within the Earth. The magma, the molten rock that erupts from beneath the surface, acts as a direct messenger from the planet's mantle. By studying its composition, temperature, and mineral content, researchers can gain invaluable insights into the chemical and physical properties of Earth's interior layers. These layers are otherwise inaccessible, lying tens or even hundreds of kilometers below the surface. The mantle, in particular, is a vast and enigmatic region that drives many of Earth's geological activities, from the movement of tectonic plates to the generation of earthquakes and the creation of mountain ranges. In addition to advancing scientific knowledge, this research has practical applications. Understanding the deep processes driving volcanic activity can help scientists better predict future eruptions, potentially saving lives and minimizing damage. For instance, subtle changes in magma composition or gas emissions might signal that an eruption is imminent, allowing for timely evacuations and preparation. This information is especially vital in regions where millions of people live near active volcanoes, such as the Pacific Ring of Fire. Ultimately, volcanic eruptions are a stark reminder of the Earth's restless and evolving nature. By studying them, scientists are not only unlocking the secrets of the planet's deep interior, but also gaining a deeper appreciation for the delicate balance that sustains life on Earth. Each discovery, no matter how small, contributes to a broader understanding of our world. A world that is alive, dynamic, and in many ways, still full of mystery. As the story of this eruption unfolds, it's clear that it's about more than just a single volcanic event. It's a reminder of our planet's immense power and complexity, the fragile balance of ecosystems, and humanity's role in understanding and respecting nature. Whether this event becomes a story of triumph, tragedy, or transformation is yet to be seen. But one thing is certain: the mysteries of the Mariana Trench and the forces shaping our planet will continue to captivate and challenge us for generations to come. So, what lies ahead? Will this new volcanic island rise to reshape the Pacific? What secrets will scientists uncover in their quest to understand this geological phenomenon? Stay tuned as we dive deeper into the Earth's uncharted depths. The story of this eruption is far from over. Beneath the tranquil beauty of the Pacific Northwest lies a ticking geological time bomb, Mount St. Helens. But now, an even more chilling discovery threatens to rewrite the story of this volatile region. The Pacific Northwest is a land of breathtaking mountains, ancient forests, and a rugged coastline that draws millions each year. Yet beneath its serene exterior lies one of the most active geological regions on Earth. Mount St. Helens, infamous for its catastrophic 1980 eruption, has long captured the attention of scientists and adventurers alike. But recent findings by the U.S. Geological Survey, USGS, have unveiled a terrifying secret: a mysterious leak on the ocean floor near the volcano. What does this leak mean for the future of the Pacific Northwest? And could it trigger a chain reaction of catastrophic events? Mount St. Helens has always been a geological enigma. Nestled along the Cascadia subduction zone, where tectonic plates collide, it's part of a volatile system prone to earthquakes and volcanic activity. In recent years, advanced monitoring tools have revealed seismic rumblings and signs of awakening beneath the mountain. But it's the nearby ocean floor that has shocked the scientific community. During a routine geological survey, scientists detected a strange anomaly: warm fluid seeping from the seabed at an alarming rate. Initially thought to be a typical hydrothermal vent, further investigation revealed something far more sinister. This leak was no ordinary outflow. It was releasing methane, carbon dioxide, and chemical compounds directly tied to magma reservoirs deep beneath Mount St. Helens. The discovery set off alarm bells. These types of leaks often act as pressure valves, signaling instability within the Earth's crust. If the magma chambers feeding Mount St. Helens are under extreme pressure, the consequences could be catastrophic, potentially leading to seismic events or even a volcanic eruption. The leak's location adds another layer of danger. It sits disturbingly close to the Cascadia subduction zone, a region capable of unleashing megathrust earthquakes with magnitudes of 9.0 or higher. Such an earthquake could trigger massive tsunamis, devastate coastal cities, and disrupt life across the Pacific Northwest. To complicate matters, the fluid escaping from the leak is laced with methane, a greenhouse gas over 80 times more potent than carbon dioxide in trapping heat. While the current emissions are small, the risk of larger methane releases looms large. Beneath the ocean floor lie vast deposits of methane hydrates, ice-like structures that trap methane gas. Even minor temperature changes could destabilize these deposits, unleashing a catastrophic feedback loop of warming and gas release. Adding to the mystery, seismic tremors, known as harmonic tremors, have been detected near the leak. These tremors, often linked to magma movement, suggest that the Earth's crust in this area is far more dynamic than previously thought. Some experts speculate that the leak could be part of a deeper, more complex geological system, potentially tied to ancient, dormant structures beneath the Pacific Northwest. The worst-case scenario surrounding an underwater volcanic eruption near the Cascadia fault leak is nothing short of catastrophic. Imagine the sheer power unleashed if volcanic activity were to occur in this already vulnerable region. Such an eruption would instantly displace massive volumes of water, unleashing tsunamis that could race across the Pacific Ocean at speeds up to 500 miles per hour. These towering waves, capable of reaching coastal cities like Seattle, Portland, and even further, would arrive in mere hours, leaving minimal time for evacuation and disaster preparedness. The impact on these urban centers would be devastating, with coastal infrastructures, ports, and residential areas swept away in the blink of an eye. The primary wave of destruction would be immediate and highly visible. Entire neighborhoods inundated, buildings reduced to rubble, and thousands of lives at risk. The force of a tsunami isn't just in its height, it's in its ability to flood miles inland, destroying everything in its path. Seattle and Portland, being major population and economic hubs, would face catastrophic losses. Skyscrapers could crumble under the sheer pressure of water and debris, while key infrastructure such as highways, bridges, and power grids would be rendered useless. The ports, which serve as vital arteries for trade and commerce, would be paralyzed, creating a ripple effect on the economy that could last for years. But the disaster wouldn't stop there. A volcanic eruption near the fault would also disrupt marine ecosystems on an unimaginable scale. The sudden displacement of water would cause shockwaves that could devastate delicate habitats. Coral reefs, already vulnerable due to climate change,